Hi everyone, welcome back. We are going to start differential equations today. So what I would actually like for you to do first is pause the screen and copy this chart in your notes exactly as I have it here, and then we will go ahead and get started. So pause it and then click play when you're ready to go. Okay, so what I have is some differential equations on the left-hand side of this table. And what I'd like to do is rewrite the differential equation with the variables separated on the right-hand side. And this is going to be the first step of any differential equation or DE that you see in AP Calculus. All right? Any differential equation you see is going to be separable. And what we mean by separable is that we can separate our variables. So we always want to get y is on the left and x is on the right. Okay? If you can't separate it, then it's not going to ask you to solve the differential equation. The problem's asking for something else. Okay, so beware. That actually happened this past year, the 2015 AP Calc exam. It looked like one of the FRQs was going to be a differential equation problem. So students tried to separate when they really couldn't, and the problem was asking for something else. So just be aware of that. All right. Let's look at this first one. Again, I want to get x is on the right side, y is on the left. So what I'm going to do first is go ahead and subtract x squared from both sides. Yeah, so I would get 3y times dy dx equals negative x squared. All right. We're actually just about there, but what I would like for you to think of this derivative dy dx, I want you to think of them as two separate quantities, like dy divided by dx. And remember, I want to get all my x's on the right side here. So what I can do is multiply both sides by dx, correct? And I would get 3y dy equals negative x squared dx. And now we're good. Right now I have y's on one side, x's on the other. And also very important that I have my differentials both in the numerator. Neither differential is in a denominator now. And you'll see why that's important in just a sec. Okay, let's try the second one. It says sine of x times y prime equals cosine of x. If you ever see y prime in a differential equation instead of dy dx, I would like for you to rewrite that as dy dx. Okay, all right, so I think the first thing I would like to do is divide both sides by sine of x. Are you good with that? So I would have dy dx is equal to cosine x over sine of x. All right, almost there. I have x's on the right side, but on the left side I have some mixes of x's and y's, right, because of the differentials. So if I multiply both sides by dx, I would get just dy on the left side. On the right side, just maybe as a little review, do you remember what cosine over sine of x is equal to? It's cotangent of x, right? Sine over cosine is tangent, so the reciprocal of that would be cotangent. Okay. All right, let's try the next one. I have x times y prime, so again, let's change that to dy dx, shall we? Equals, over e to the y plus 1 equals 2. Okay, so what would you like to do first? We could multiply both sides by dx first, if you'd like. If you can, you could do this all in one step. Multiply both sides by dx and divide both sides by x. So what you would end up getting is, and you don't have to do this all in one step, but if you're ready for it, you sure can. You'd have dy over e to the y plus 1 on the left side. And remember, to get rid of the dx, I would need to multiply by dx. To get rid of the x, I'd need to divide by it. So on the right side, I would have 2 divided by x dx. Okay, last one. I have y times the quantity x plus 1 plus dy dx equals 0. Do you see anything different here? Okay, for the first time, the dy dx is being added instead of multiplied, so we're going to need to be kind of careful here with how we do things. So what I'm going to suggest is first go ahead and move this whole term over. I know that's not where we want our y's, but we can get there if we move everything over first. So subtract by the quantity y times x plus 1. Okay, now do you see where we can go? We could multiply both sides by dx to get the dx over here, and then divide both sides by negative y to get the y over here. All right, so where that would take us is dy divided by negative y is equal to x plus 1 times dx. Okay, again, this is the first step in solving any differential equation, so I want to do just a few examples where we just work with separating the variables. Okay. All right, if you'd go ahead and write this example down, please. We're still not going to solve a differential equation quite yet. If you had pre-calc here last year at the very end with our Intro to Calc unit, we gave you some problems like this, where you just had to do the algebra part of solving differential equations. So we took out all the calc part, which is actually the easy part. We'll get to that, kind of put all the pieces together here after these next two examples. But we took out all the calc and we just asked you, we set this up with some constant that we don't know. And we asked you to find the constant and then solve for y. Okay, so these problems are, the algebra part is a two-step part really. First, find the constant. And do you remember how we did that? We would use the initial condition that was given. Remember, f of 0 equals 1/2 can be written as the ordered pair 0, 1/2, right? So this is x, this is y. We plugged those in to get c. Once we got c, we plugged that back in and then used algebra to isolate for y. Okay, this is going to be the very last step of your differential equations, and it's typically the most tedious step, to be honest. But if you have a differential equation in your FRQ, the algebra part is typically just worth 1 or 2 points. However, that is 1 or 2 points, and sometimes that's all the extra we need, right? Okay, so let's start by finding c. So I'm going to plug 0 in for x, 1/2 in for y. So I'd have e to the 2 times 1/2, which would be 1, right, equals 0 plus c. Okay, so it looks like c is equal to e. Okay, all right, now we are going to plug what we found for c back in at this point. So I have e to the 2y is equal to x cubed plus e. All right, now I would like to get y by itself. Notice that there's only one y that occurs. It's right here. So the first thing I need to get rid of is this e. So what undoes e? What's the inverse of e? Well, the inverse of the exponential function e to the x is ln of x. So if I take ln of both sides, what happens is these undo each other, right? And you can think of the power rule if you want to fly this forward, and then ln of e is 1, right? So on this side, I have just 2y left. And then on this side, I have ln of x cubed plus e. All right, now divide both sides by 2, and you get y equals ln of x cubed plus e divided by 2. Then I'm just going to keep it like that. You could rewrite using the power rule if you'd like, but this is good. Now, before you box your answer and say that's that, always go back and double check. Do you remember doing that? So I'm going to plug 0 in for x, 1/2 in for y, and see if I get a true statement. So does 1/2 equal ln of 0 plus e is going to be e divided by 2? Well, yeah, it does, because ln of e is 1, right? So I have 1/2 equals 1/2. So this is indeed my final answer. Okay, always go back and check, because after you did all that work, the nice thing about these problems is at least we can go back and check our algebra. Okay. All right, let's try another just doing the algebra, and then after this example, we'll do some all the way through. Okay, go ahead and write this example down. We have ln of the absolute value of y minus 1 equals 1/3 x cubed plus c. Now remember, f of 0 equals 3 can be written as 0, 3. So x is 0, y is 3. What's the first thing we're going to do? Well, the first thing we're going to do is plug in that ordered pair, right, and find c. So ln of the absolute value of 3 minus 1 equals 1/3 times 0, right? So 0 plus c. So it looks like c is equal to ln of the absolute value of 3 minus 1. 3 minus 1 is 2, and the absolute value of 2 is 2. So c is equal to 2. Okay, what now? Now we plug ln of 2 in for c into this piece here. So ln of the absolute value of y minus 1 is equal to 1/3 x cubed plus ln of 2. All right, now I would like to solve for y, right? And there really are a couple routes you can go here. When you have more than one ln, my recommendation is put all your ln's on one side, everything else on the other, and then we can use our laws for logarithms to simplify. Okay, so let's do that. We have ln of the absolute value of y minus 1 minus ln of 2 is equal to 1/3 x cubed, right? Okay, now the laws for logarithms say if we have subtraction in between these logs, I can combine these logs using what operation? Division. Just don't lose your absolute value bars there, please. Okay, now I have just one ln, which is not as intimidating to work with. So again, what's the inverse of ln? Well, it'd be e. So if you exponentiate both sides, what I mean by that is take e to this power equals e to this power. The e and the ln will have that undoing effect on each other. So we have the absolute value of y minus 1 over 2 equals e to the 1/3 x cubed. Again, we want to get y by itself, so at this point we can multiply both sides by 2. Now what do we need to get rid of? Well, now we need to get rid of the absolute value bars, right? Do you remember how to do that? For that, we just put a plus or minus on the other side. So if you want to drop absolute value bars, you can simply put a plus or minus on the other side. And we're just about there, right? Add 1 to both sides. You get y equals plus or minus 2e to the 1/3 x cubed. Now, do you remember from pre-calc why this is not an acceptable answer? Well, they asked us to find a function, right? And this cannot be a function because it has a plus or minus. It has two outputs for most inputs. So how did we find which branch to take, the positive or the negative? Well, we found that by going back to our initial condition, right? So plug in, remember I said don't box that yet, always check your answer. So at this point, check your answer. So x is 0, y is 3. So we need 3 to equal 0 plus or minus 2e, I'm sorry, not 0. One plus or minus 2 e to the 0, right? Okay. Well, e to the 0 is 1. So which one do I want? Do I want 1 plus 2 or 1 minus 2? I want 1 plus 2 because I want to end with 3, right? So my final answer is going to be y equals 1 plus 2e to the 1/3 x cubed. And I know that that checks out now. I checked that on the left there. So that is our final answer. So in that case, we wanted the positive branch. All right. Okay. Well, are we ready to do one for real? Okay, go ahead and write this one in your notes. We have y prime equals negative x divided by y. And we want to find the particular solution, so that means we want to solve for y, to this differential equation, given that the initial condition is what? How would I write this as an ordered pair? 2 comma negative 2, right? X comma y. Okay, before we get started, would you take a look at your homework from yesterday when you had to draw the slope fields? Didn't you have one like this that said y prime, or maybe do y dx equals negative x over y? If you look at that, what does it look like? What kinds of shapes does it look like you made? Hopefully they look like concentric circles. Yeah? What I'd like for you to do is put your pencil at the point 2, negative 2. And follow the slopes right there. And draw through that circle. It's actually going to need to be a semicircle, right? Because I want it to be a function. I want it to pass the vertical line test. So draw that semicircle that goes through to negative 2 and follows the slopes that you drew yesterday. Okay, so I want to do a bit of prediction. I want to see if we can figure out what our answer is going to be here based off your graphs before we even do the calculus. And this is not, the problems are typically not this straightforward, but given the picture that you have, we know that our answer needs to be the bottom branch of a semicircle, right? So do you remember the equation of, first of all, equation of a circle centered at the origin with radius r? Well, it's x squared plus y squared equals r squared. It's really just the Pythagorean theorem. What is r in your case? In your case, r is Can you tell? It's difficult to see. It's not a perfect number. But let's just go with this. X squared. Yours is not a rational number, so it's difficult to see, but we can go with just r squared. Okay, so if I wanted to solve for y, I'd get y squared equals r squared minus x squared. And then I'd get y equals plus or minus the square root of r squared minus x squared. And in our case, since it's the bottom half of a circle, I'm going to want the negative root. Okay, so my prediction is our answer is going to look like this for some value r. Okay. All right, let's see if we can solve this differential equation here. So I have y prime equals negative x over y. So think about what we were doing in the beginning there. The first thing I had you do if I had y prime was what? I'd like for you to rewrite that as dy dx equals negative x divided by y. Okay, now we have to separate, right? So I want y is on the left side, x is on the right side. So what do you think about multiplying both sides by y and multiplying both sides by dx? So I would end up getting y dy equals negative x dx. Do you agree with that? Okay. All right, so now we have the actual calculus part. So why do we do this? Well, now what you're going to do is integrate. Okay, so I'm going to take the integral of both sides. And I'm actually going to pull that negative out in front. Just again, I like to not worry about my constants in the front, coefficients. All right, now I have the integral symbol combined with dy, which means what? Find all antiderivatives of y, right? Which is going to be y squared divided by 2. Technically plus c, but what I'll do is this one's going to have a plus c too, so I'll just put it on the right side. So this one, the negative comes along for the right. The integral combined with the dx means find all antiderivatives of x. So negative x squared over 2. Again, we'll put our plus c on the right side. And now we're back to the pre-calc form, right? Now we're back to what you're used to. So what do we do from here? Well, we plug in our initial condition, right? So 2 for x, negative 2 for y. So negative 2 squared is positive 4. 4 divided by 2 is 2. And then we have negative 2 squared over 2. So that'll be negative 4 over 2, which will be negative 2 equals c, right? So if I add 2 to both sides, it looks like c is 4. Okay, what do I do now? Now I come back to this point where I had c, and I plug in what I now know c is. So I have y squared divided by 2 is equal to negative x squared divided by 2 plus 4. I want to solve for y, so what's the first thing you do? Well, my only y is already on the left side, so let's get rid of this 2. Let's multiply both sides by 2. So I get y squared equals negative x squared plus 8, right? And now what? Square root, but I need plus or minus. Okay, how do I choose plus or minus? We go back to the initial condition, don't we? So we need to plug the initial condition in. The initial condition was y is negative 2. X is positive 2, so that would be negative 4 plus 8, just plugging into this last step I had here in blue. Maybe connect those. Okay, so negative 2 equals plus or minus square root of 4, right? So negative 2 equals plus or minus 2. Well, obviously we want the negative branch, right? So my final answer is y equals negative square root. And if you'd like to rewrite this, we sure can. So that your negative is second. So y equals negative square root of the quantity 8 minus x squared, which is exactly what we predicted up here, right? So your radius is actually the square root of 8. That's why I said it might be hard to see exactly what the radius is, but it is in the form that we predicted there. Awesome. All right, let's do one more, and then what we can do is do the first one from your homework. Okay, so go ahead and write this one down in your notes. We have dy dx is equal to e to the y times the quantity 3x squared minus 6x. All right, already written as dy dx, so that's good. My initial condition is 1, 0. So what do we want to do first? We'll separate, then integrate, right? So first we're going to separate. So what do you think about dividing both sides by e to the y and multiplying both sides by dx? So we'd have dy over e to the y equals 3x squared minus 6x dx, right? Okay. This guy, I think will be easier to see if you rewrite this in some way. So how could you rewrite 1 over e to the y? Well, how about you just bring that e to the y up to the numerator, but make the exponent negative, change the sign of the exponent. So I could change this, bring it up here, like so. We buy that? Okay. All right, now, so we separated, now we integrate. Separate, then integrate. All right, so this integral symbol combined with the dy means find all antiderivatives of e to the negative y. So if you differentiated this, what rule would you need? You'd need chain rule, right? You would do e to the negative y, differentiate the mom, and then multiply by the derivative of the baby, which is -1, right? Since we're integrating, and since our derivative is just a constant, you can just divide by -1. So you'd have e to the negative y divided by -1, which is still just going to be negative e to the negative y. All right, and we'll put our plus c on the other side. So antiderivative of 3x squared is going to be x cubed, right? Antiderivative of -6x is going to be 3x squared plus c. All right, as soon as you have that plus c, I'd like for you to plug in your initial condition because at this point now we are into the pre-calc stuff. Okay, so I have x is 1, y is 0. So I have negative e to the 0 equals 1 minus 3 plus c. Well, anything to the 0 is what? Is 1. So I have -1 equals -2 plus c. If I add 2 to both sides, I get that c is 1. Okay, what do I do now? Well, now we plug c back in, right? Into where we first saw c, where we first introduced c, right there. All right, so I have negative e to the negative y equals x cubed minus 3x squared plus 1. All right, I'd like to solve for y now. Notice there's only one y. It's already on the left side. Everything else is on, well, the x's are on the right side. So the first thing I'd like to get rid of is this negative here before you do anything. All right, that negative does pose a problem. So how about we just switch the signs on everything, divide both sides by -1. So I'd have e to the negative y equals negative x cubed plus 3x squared minus 1. Okay, now I want to get rid of the e. So what gets rid of e? we take the natural log of both sides, right? And now what? Now just divide both sides by -1. Okay, are we done? Let's check. Let's check our work. Okay, how do we check our work? We'll plug the initial condition into your final equation and see if you get a true statement. So does 0 equal -ln of -1 plus 3 minus 1? Well, we have 3 minus 2, which is 1. And ln of 1 is 0. So that works. So this is our final answer. Always make sure you know what your final answer is so that the AP readers know that this is just you checking your work. Okay. All right, well, that's it, guys. I will go ahead and do the first one from your homework if you'd like. So let's look at page 431, number 15. So this is page 431, number 15. And we have, it looks like y times dy dx minus 2e to the x is equal to 0. And it looks like my initial condition is 0, 3. All right, what's the first thing we do? First thing we do is separate, right? So separate your variables. So what do you think about adding 2e to the x to both sides? Okay. All right, we're just about there with separating. Now we just need to do what? Just multiply both sides by dx. And we get that. All right, we separated. Now what? Now we integrate. Okay, so I'm going to take the integral of this. Again, I like to pull my coefficients out of the integral. That's your call. All right, so integral of y dy, or in other words, find all antiderivatives of y. That'll be y squared over 2 plus c, but we'll put the plus c on the other side. What is the antiderivative of e to the x? Well, that would just be e to the x, right? Plus c. Notice that that coefficient of 2 came along for the ride. Okay, now what? Now we plug in our initial condition of 0, 3, right? So 3 squared is 9. So I have 9 divided by 2 is equal to 2 times e to the 0, which is 1, right? So 2 times 1 is 2, plus c. Okay, now I want to subtract 2 from both sides. 2, we need to write that with the denominator of 2, so that'd be 4 over 2, right? So 9 halves minus 4 halves is going to be 5 halves. All right, so c is 5 halves. Okay, what now? Now we plug that c value back into when we first introduced c right here, right? So y squared divided by 2 equals 2e to the x plus 5 halves. Okay, I want to do what now? Solve for y. So how would you do that? Should we multiply both sides by 2? So y squared equals 4e to the x plus 5, right? Those 2's are going to undo each other. Now what? Now square root both sides. Do not forget your plus or minus. So square root of 4e to the x plus 5. And now what? Now we check our work, and in so doing, we'll be able to choose which branch we want, positive or negative, right? So let's come over here. 3 is equal to plus or minus the square root of 4 times e to the 0, which is 1. So 4 times 1 is 4, plus 5. Looking good for us, right? Plus or minus square root of 9, which is 3. So we want which branch? We want the positive branch. So y equals square root of 4e to the x plus 5, and that's our final answer. Okay. All right, guys, so you have a few problems from the book to do. Sometimes I think the book does not always take it that last step and solve for y. You need to make sure that you do, okay? And then you also have 6 problems from APSI, okay? So for your 6 problems from APSI, I have solutions here, so you can take a picture, screenshot, or pause the video. I have what you should get before you do the last part of algebra and solve for y. So the blue is what you get right before you solve for y, and then the red is your final answer. So you can kind of check before you get to your final answer to give you just some checkpoints there. All right, so this is your APSI, page 174, but go ahead and do the bookwork first. I think the bookwork's a little bit easier, so that'll be a good place for you to start, and then you can finish off with these 6 problems. And if I'm remembering right, I think one of these 6 problems is the same as one of the ones from your book, but just go ahead and work it twice. No harm there. All right. Okay, guys, good luck. And I will see you next time.